As always, tech series, extra credit, extra credit. Today's session is on ethics, so 5 p.m. You know the link is always the same up here. We have the tech series tonight. It's on ethics. Don't know what that's going to entail, but if you're interested in ethics, you want to be it. Or if you want extra credit, you should be it. If y'all are like on campus during the time this is going on, I'd be in room 205 with it on the projector. So if you want to like watch it like this in this type of setting, that's cool. What's up?
Do any of the other times like have the same meeting going on, like 3 to 4, 6 to 7?
These just the other time zones.
Oh, okay.
So, cause it's like schools across the country be joining. So, yeah, for us it's 5 p.m. Questions on the tech series tonight. All right, bet. So today's lesson is going to be on loops. We have a special kind of loop, which is called a while loop, and this is sort of similar to something that we've seen with conditionals, but essentially this allows us to do more with programming. So questions before we start. All right, bet. So I'm going to go into what a while loop is. We're going to see examples, why we need it. Still using while loops, I'm going to show you what a counting loop is. It's still using a while loop, but it's to do something a little different. And then we're going to try to get into a quiz review. It's not going to be Kahoot today. Y'all have study guides that y'all can work on with each other or in groups or by yourself. It's up to you. But I want to give you as much time as possible for that. But I have to teach this. So ask your questions. We're going to get through the lesson, and then hopefully we have enough time for in-class quiz review. Cool. So while loops. And I'm going to need y'all to help me out. My password, let's say my Gmail, my bank account password is one of these fruits, right? It's one of these fruits. Guess my password.
Grapes.
Nope.
Watermelon.
Nope.
Kiwi.
Nope.
I love pineapple. Grape.
Nope.
Cherry.
Nope.
Fruit cocktail. Broccoli.
Blueberry.
Watermelon.
Blackberry.
Nope.
Strawberry.
Tomato.
Bro, what's that fruit right there?
Starts
Is it a lemon?
with, lemon. Lemon is my password. Not my real password, but for the example of this, lemon was my password. So thinking about what steps did we just go through, right? Yeah, basically. We started with a first guess. I said, what's my password? Y'all started guessing. I examined each password. I listened to it. And I said, is that my password? So I compared what you guessed with my actual password. If it was wrong, I accepted more password guesses, right? Until you finally gave me the password that I was looking for. We had to just keep asking for more and more and more. Once we finally got the right password, we stopped. So that's essentially what I'm outlining here. I said I started with the first guess. If that was wrong, we went through a process of accepting more and more guesses, right? With each guess, I had to listen and make sure that wasn't my password before I asked for the next guess. When I finally got something that was correct, I stopped asking for guesses. I stopped. Once I finally heard lemon, I stopped. Until I heard lemon, I had to keep checking for more. I had to keep accepting more guesses and checking if that's my password. So this essentially, in something close to code form, is how we're going to approach loops, right? Until we reach some condition, we want to keep doing some steps. So what is a loop, right? What is a loop? A loop essentially just allows us to repeat some steps over and over and over and over so that we don't have to manually type out those steps every time. We can just say C++, run these steps 100 times, or run these steps until the user guesses my password right. Run these steps until something. That is what a loop is for. So thinking about how we did if statements, right? We know that we had if, our parentheses, inside of here lies our condition. Our condition boils down to true or false, right? If the condition evaluates to true, we know that we do something. right? Whether it's see out or call some function or exit, whatever it is, we do something. Only if the condition is true. And so everything inside these curly braces only gets executed if the condition evaluated to true. Only if it was true. If it was false, we know that we skip over this entire thing. And so then we know the if statement only happens once. So we're going to check this condition one time. If it's false or true, we're either going to do what's in here or not, and then we're just going to continue executing the rest of our code. With a loop, we're going to keep going and keep going and keep going and keep going until this condition becomes false. So same idea, like I said, with if, we want to know, is this condition true? Is this condition true? If it is, we're going to do what's inside. Same thing with a while loop. We're going to check, is this condition true? While this condition is true, we're going to do everything inside of it until the condition eventually becomes false. So thinking about the idea of guessing my password, right? Every time I asked you for a password, it was wrong. It was wrong. It was wrong. When it finally became true, that's when we stopped. Until the password became correct, we had to keep asking for more password guesses. So essentially, something in this block should eventually make the condition false. That's the only way it can stop. Because if nothing in here mutates the condition will always be true and it'll run forever. So something in here has to change the condition and make it false, i.e. make it stop. And I'm going to show more and more examples, but is the concept kind of making sense? Like, okay, we're repeating steps over and over again, and then we need a way to stop. Anybody lost, like, the concept isn't really sticking so far?
So it doesn't stop, it just keeps going?
It has to stop, but we need to tell C++ when to stop.
Oh, okay.
So, for example, like we're guessing my password, right? We knew the condition to stop that loop was when I heard the correct password. So we can represent a whole bunch of like real world scenarios with a loop. And the two like main ideas with a loop are, what steps do I want to repeat, and under what condition can I stop repeating those steps?
Okay.
So those are like the two main ideas. So just to reiterate, this loop will run as long as this condition evaluates to true. As long as this thing up here is true, we're going to run what's inside of it. So hence, something inside of it needs to eventually make the condition false at some point, or the loop will just run forever. And that's called an infinite loop, and you never ever want that. Questions on the concept of a while loop?
Go back to the definition.
Yeah. So like I said, right? With us guessing the password, while the guess is wrong, keep allowing more guesses. That was pretty much the process we went through for you all guessing my password. While you couldn't guess it correctly, I'm gonna allow you more and more and more attempts. When I finally heard the correct password, this statement became false. The guess was no longer wrong. In this case, it's a little harder to wrap your head around it because it's like, I want the inverse, right? I want to run this loop as long as the guess is wrong. I want to keep asking for more guesses while your guess is wrong. Once your guess becomes correct, we break out of this loop and we don't ask for any more guesses. That's the concept behind it. Questions on that? It's not making sense. This sounds crazy. Yeah, okay. So essentially, somewhere in this code, we will need to ask the user for another guess, so that the next time that we get back to the top of the loop, we're checking with that new guess. We'll check the new guess. If it's still wrong, we're going to go into the loop, ask for another guess. Once we get that new guess, we'll return back to the top and check that new guess. We're going through the same process. Every step in here will be repeated as long as this condition is true. And so once our actual guess or our actual password matches the actual password matches the guess, that's when we can finally stop. Because our condition is satisfied. Our condition is finally satisfied.
So, like the password situation, it just like automatically, like, you guess the random numbers.
Say that one. Does what automatically?
Like the wild thing,
Mm-hmm.
it like, if it's wrong, you say like, try to guess more.
So we have to tell it how to ask more. Like we have to do cout, enter a password, cin, store the password. Once we get back to the top, I'm gonna show you the code for it, so hopefully it paints like a much clearer picture. But basically these are just the concept. So I left these as like not in code form because it's just a concept. So it reads like English and hopefully resonates. While the guess is wrong, keep asking for more guesses. That's kind of like the thought process behind how this type of while loop will work. While some condition, do something. And so here's a breakdown of that. So remember, we start the loop. The condition is the password wrong? Did the user guess the password wrong? That's the condition. If the user did guess the password wrong, we go back to the start of the loop. We ask again, did the user guess the password wrong? If so, we go back to the start of the loop. It's not until they guess it correctly that we end the loop. We only end the loop once they finally give us what we want. So this is essentially a way to force the user into doing something specific. And I'll go back to this in case y'all want a picture. So this allows us to force the user. Like until you guess my password, you cannot do anything else.
Right. What about situations where you can try a password just a couple of times only?
Yeah, exactly. So that's gonna be like the second part of the lecture, like where you want it to be count based. So like I only want to give the user 3 attempts or 5 attempts. We can do that as well. The base of the while loop though is just like until this condition, which would be guessing the password correctly, that is gonna be like our overall condition for the while loop. But we can also have 2 conditions or 3 conditions, just like an if statement. We can say, while the user didn't guess my password and they didn't exceed the 3 attempts, we'll let them keep attempting. So like it's pretty much the same setup as an if statement, except this one runs until the condition finally becomes false. So I'll do a demo so we can see what this looks like. And so basically I'm just gonna implement the idea of the password guesser. I'm gonna implement the same idea. So let's say I have some string called guess. And what this is gonna do is every time I ask the user for a guess, we're gonna store it in that variable. So I'm gonna annotate it with a comment. I'm gonna say this variable stores the user's guess. And so with a while loop, instead of if, we're gonna start with while. Same setup. You're still gonna have your parentheses and your curly braces. This is the template. So we know some code is gonna go in here and a condition is gonna go in here. So can somebody remind me, what is our condition that we wanna run this password guesser? How long do we wanna run it for? What's our condition to break out of the loop? The right password. So if we want the right password, we should run this loop while they're given the wrong password. So sometimes you gotta think about it in the inverse. Like in this case, we know our goal is to get the right password. So we want to trap them while they're giving us the wrong password. In this case, we're trying to trap the user and make them do something specific. And until they do that thing, they can't do anything else. We're trapping them. So while the guess, and remember I said my password is lemon. So while the guess does not equal lemon, we want to prompt the user for another password and another password and another password and another password. So to prompt the user, we know we have cout, enter another password. And we're going to store it in our variable called guess. Questions on this?
It's really like the same as the if statement, is just better. In my eyes, like as far as the format, it's like type to go. Not as far as what they do.
So let's say I have like showing like the template for if. So maybe compare it to like an if, right? We know it's the same setup pretty much. Your keywords is the only thing that's really changing. Inside the parentheses is still going to be a condition, and then inside the curly braces is going to be your code that's going to execute. This specific case, I think, is a little tricky because we want the inverse of what's actually intuitive. Like in this case, while they're given the wrong password, we want to keep asking them for more passwords. I think the most intuitive case would have been a case where it's like, while something does equal something else. I think that would flow a little easier. Did that answer that at all? Okay. So I'm gonna take that out. So the only caveat to this is gonna work, but the caveat to this is when we created a variable, right? Created a variable called guess, and then on line 12 we try to use it. We never gave it a value. So what C++ is going to do is say, how can I compare these values when guess does not have a value yet? So what we're going to do in this case, and what you'll end up, question.
What you the condition that you put, is it telling them anything that you put that's not lemon?
Yep. Anything that a user enters that's not lemon, we want to keep asking them to enter something else. Good question. So because I never gave guess a value, I'm going to just ask for like an initial value from the user so that it has something. Or I can just set it to be like empty. I can set guess to be empty. So what this is going to do is say the initial guess is nothing. So when I compare nothing with lemon, we know that that's true or false. False. Nothing does not equal lemon. So I'm going to prompt the user for another password. Whatever they enter, I'm going to store it. And remember, the loop just returns back to the top of the loop. So let's say I enter strawberry. It's going to store strawberry. It's going to go back to the top of the loop. Guess is now equal to what? Strawberry. So it's going to compare strawberry with lemon. That's true or false? False. So everything in here is still going to happen. Let's say I guess blueberry. I'm going to store blueberry. Go back to the top of the loop. I'm comparing what two values now? Blueberry and lemon. That's still false. So we still track until we enter lemon, and lemon gets stored here, and we actually compare lemon and lemon. This loop will continuously run.
Okay, does it matter how lemon is written, or does it
Yeah.
have to be like exactly?
It has to match exactly, and that's just based on how we defined our logic,
Oh,
right?
okay.
So just like an if statement, you could have said if the first letter of both of them match, or like it's based on what your need is. If you only care about the first character matching, then that's what you would say here, just like with an if statement.
Okay.
So I'm gonna try to run it and see if I got some errors. So enter another password. So let's say I do blueberry. Enter another password, strawberry, kiwi, lime. Until I enter lemon, this thing will continuously run. It can run infinitely. Until I finally satisfy this case, it's gonna keep running. It can run as long as the user is guessing the wrong thing. So basically we're trapping the user and saying, yo, you can't do anything until you do what we're telling you to do, which is just like how a normal password checker works, right? Until somebody actually puts in the right password, they can't log in. They cannot log in. Does this make sense? And this should be public on Edstem if you want to pull it up. I see some of y'all in here.
Like, I understand it, but can you explain line 8 again?
Line 8. I figured that was going to be like a...
Yeah. So what are you doing? Like you just storing the variable?
Yeah, so basically, let's say we don't give that a value. This is normally how we write our stuff in our programs in this class, right?
Yeah.
On line 12, however, I need a way to get into this loop. The only way to get into this loop is if the guess does not equal limit. Well, what is guess? Guess doesn't have a value yet, so we can't compare a non-existent thing to something that exists.
Oh,
Question.
Can you ask them to enter?
Yep. So the normal way would just be to insert an initial guess and then just store that. And this is probably what you're going to want for your homework. For your homework, you're probably going to want to prompt the user one initial time before you even go into the loop so that your conditional value actually has some type of value. So I could have left it as this. I could have given like hard coded a value, but that's not the best way to do it. You want to actually ask the user for an initial guess because they could guess it right on the first time. And maybe, so if they guessed it right on the first time, we would never even go into this loop. We would never even go into the loop in the first place. And that's kind of how a real password checker will work, right? If I already know my password and I type it in correctly, there's no reason for the program to prompt me for another password because I guessed it right already. Questions?
Wait, so line 10 and 11, basically, is that like replacing storing the variable?
So 10 and 11.
Yeah.
So remember, we created the variable, right?
Yeah.
It needs a value down here. It needs a value. So what we're going to say is we're going to get an initial value from the user.
Oh, so we get the initial value from 11?
Yep.
Okay.
Exactly. So we're going to do CN. We're going to prompt the user for an initial guess, and I can run it to show you. And if that initial guess is correct, we should never even go into the loop to begin with because the initial guess was correct. So let's see if I'm just BSing or if that was right. So they asked it for an initial guess. My inference is that if I enter lemon, the program is going to shut off because I guessed it right. Let's say we entered lime. What should happen if I enter lime?
Enter another password.
Exactly.
Alright.
And we trapped here until we enter lemon. Questions on this?
Can you go back up to line 8 so I can see it a little bit? Like, you did the cout after, like, you took away the established variable, then you did a cout for initial value.
Yeah. So instead of hard coding it like this, because that's not fair, right? It's not fair to say the user guessed a blank string because they didn't, right? They didn't guess anything yet. So to be fair, I'm gonna say enter your initial guess because they could get it right. This might be the real user, right? They might not even be guessing. They might know the password. This might be your account. So I'm gonna say enter an initial guess, and I'm gonna store that, and I'm gonna use that as the initial check. So the first iteration of this loop, I'm gonna be comparing lemon and lemon. And we know lemon and lemon. So we want to know, does this guess not equal lemon? In this case, lemon does equal lemon, so there's no point in even going into the loop. There's no point. Questions on this? Bet. So I think we're starting to see the point of a loop, right? To repeat steps over and over again. But what is, I'm gonna tell you the point of a loop in general and then the point of the for loop the while loop specifically. So this obviously allows us to repeat steps that we specify one time. We tell C++ what those steps are, which in this case would be 18 and 19. We specify the steps that we want repeated, and this will run as many times as we need it to. So let's say, for grins and giggles, let's say I wanted to print out let's create a new file so this can like actually make more sense, right? Let's say. Let's say I wanted to print out good morning 5 times. How would I do that? Using, let's say I have one of them. How would I print out, without a loop, how would I print out good morning 5 times? So just copy and paste it, basically. So let's say I wanted to do it 10,000 times. Let's say I want to do it 10,000 times. What do I do at that point? Exactly. Exactly. At this point, a loop becomes absolutely necessary. It becomes necessary because it's like, yeah, there's technically a way to do it without a loop, but it would be like too much of a headache as a programmer to even make that happen without a loop. So this is kind of the need and the reason behind loops. Like we can automate stuff and say, do this specific thing this many times, or do this until this condition becomes false. That is like the premise behind a loop. So why use a while loop? So again, this forces the user to satisfy the condition.
You're not gonna actually teach us how to copy and paste it?
Nah, I mean, what, 10,000 times?
Yeah, like how do you do it?
With a loop? Yeah, we about to see in like 6 slides. Like 6 slides. So the reason behind a while loop specifically is this forces the user to do something, and until they do that thing, we will not move on. That is the point behind this specific loop. And there's different kinds of loops, so you want to know the reason for using each one. Because at work, I may be given a job, right, and I have to determine, should I use this one or that one? And let's say I write a whole bunch of code that uses one type of loop, and I get some pushback. Now I have to go and delete everything and alter it, and I look like I don't know what I'm talking about because I used the wrong loop when I was taught the correct loops. So make sure you understand the pros and cons for each loop. A while loop is for what? No, not for not specifically for passwords. I mean, that was one example, but
Satisfying a condition?
yes. Most importantly, that it forces the user to do something. Until they do that thing, we will not proceed. You can think back to passwords though, and how like you can't log in without your correct password, right? While you enter the wrong password, you will not get in. That's the premise behind a while loop. And the flip side of that is, let's say you don't know how many times to run the loop. That is one of the other like reasons for using a while loop specifically. So let's say the password guesser. I had no idea how many times it was going to take you out to guess my correct password, right? I couldn't say run this loop 5 times or 10 times or 20 times because I needed you to get the right password to let you in, and I didn't know how many times it was going to take. So a while loop just says while you guess the wrong one, keep asking the user. So the key word that you'll notice like when you want to think about while loop is until. Until the user or while the user. That is how you know you want to use a while loop.
So let's say, just an example. So let's say you're playing like God of War or like COD, right? Is there a condition that you have to, like maybe kill this villain before you can move?
Exactly. You can think of it in terms of game levels. Game levels, right? Until the user does whatever, keep them on this level. Great question. Other questions. Is it starting to make a little bit more sense now? Like, okay. All right, bet. So we already saw the first example, which was password validation. I added another one, right? Musical playlist. While the user hasn't pressed pause on the playlist, let's say I press play on the playlist and I fall asleep. While I haven't pressed pause, it's just gonna continue to play music and play it and play it and play it until I finally press pause or my phone dies or something like that. But until I finally do something, this playlist is just gonna continue to play. It's gonna continue to play. So maybe give me like two more, maybe three more examples of a real world scenario where your mind is thinking loop. This thing is continuing to happen over and over again until some case finally happens.
A printer.
A printer. And so let's say I print off 50 copies and bet you.
You get the joke.
So boom, let's say printer prints or while there are more copies to print, continue printing.
Or paper.
Huh?
Or paper.
Paper?
Like if it runs out of paper, then obviously it's gonna stop.
Oh, yeah. So maybe I can make that like another, because that would be, it's the same like concept, but I think that one's based on a different condition. So while there's more paper, allow user to continue printing. Is that accurate? Bet. One more, two more. Yo.
Maybe on the phone, like your battery percentage is not zero.
Phone battery. While there's more phone juice, allow user to continue using it. One last one.
Maybe like your computer, if your percentage is not lower than 20, don't put on battery saver.
Okay. Let's say laptop battery. While the battery percentage is above 20, do not show, what is it called? Battery saver. Cool. Perfect. So this is gonna be on EdgeStem. These are real world scenarios where you want to loop. Something is continuously being checked, and until some condition happens, this loop is just gonna continue to run and run and run and run.
Maybe multiple wild statements.
Yep.
Like how else if.
Mhm.
Like wild if.
So let me take it a step back. So you know how like if it can be if and then like 10 conditions in here, and only under those 10 conditions will this code happen. Same applies to while. So like while can be based on one condition or 10 or 5 or a million. It's the same exact concept. So it can be based on as many conditions as needed. So let's get back. So a hint of when you will need a while loop, and I kind of went into this a little bit a second ago. Until is the main word, hence on your quizzes and your homework, where you will know you want a normal while loop. When you see until or while something, you know you want a while loop. Again, if you see until, you know that this is indicating we don't know how many times to run this loop. We just know we're going to stop it when some condition becomes true or false. So let's say I had a while loop, right? And I want to run this loop while 3 is greater than 0. How many times would this loop ever stop? No, because 3 is always greater than 0. There's nothing we can do in here to change the fact that 3 is greater than 0. This is called an infinite loop. This is like the worst thing in programming because it's a headache. And normally when you're dealing with like 5, 10 conditions, one of them is making this whole thing true all the time. So you want your condition typically to be based on variables because variables change. They change in value. These numbers are what they are. We cannot change them. We can't change the fact that 3 is greater than 0, right? It's just math. So in that case, we know that 3 will always be greater than 0, hence this loop will run eternally.
What if you put an exclamation mark in front of the parentheses?
Yeah.
To like negate it?
Yeah, so if you negated it, this would never run. It would never run. Cause we know that if we're saying that, in that case we would be saying 0 greater than 3. So we're saying run this loop while 0 is greater than 3. And that's never going to be the case. It's never true. Good question. So how to avoid an infinite loop? Like I said, you normally want some value in the header, which is this line. One of these values needs to be changeable, mutatable. So that somewhere in here, when we do mutate it, and we get back to the top of the loop, there's a chance that maybe this will break us finally out of the loop. Just like when I was asking for the password, right? The guess variable was what was changing every iteration of the loop. So basically, we're plotting on and planning for this value to finally break us out of the loop based on what happened inside our curly braces. So I'm gonna go back to the example just to kind of, let's see. So again, if we had, let's say we had this. Let's say we have, while lime does not equal lemon, run these steps. How many times would this loop run?
It's gonna run
Forever. Because lime is never going to be equal to lemon. Never. Never ever. It's not possible. So instead, we need something that's subject to change, i.e. a variable. A variable we know is changeable. Think math. Variables change in value all the time. That's like their sole purpose. Something that you can change. So in this case, we're saying guess has a certain value right now, but inside this loop, we're going to do something and it's going to get a new value. So the next time we get back to the top of the loop, we're going to check with that new value. And basically every time we go through a new iteration of the loop, we're hoping that it finally has the value we want so that we can be done with the loop. That's the concept behind it. So instead of using like raw values in your condition, you want to actually use variables. And I'm going to show some more examples of how to do that. So like I said, otherwise, the condition will just be true all the time, and there's a chance that we just never, ever, ever end. And then we'll just see an infinite loop. And I'll actually show you like what that looks like. Some programs, like, it just stops after it realizes it's never going to end. Some of them, it just runs literally forever. So in my condition, I'm saying run this code while lime does not equal to lemon. And so maybe I should take this out and just do like a print statement. So let's say I compile that and I run it. Enter initial guess. It doesn't matter what I put in here, actually. And so see how it's just continuously running and running and running and running and running. It's like there's no way to break out of it at all, because this condition of lime not equaling lemon is forever going to be true. It's forever going to be true. So this loop will never ever break out unless I like force quit it. So this happens like on a daily basis as a programmer when you're dealing with loops. It's like sometimes you just get stuck because your condition is a little messed up. So you just get stuck in this loop and there's no way to exit. I'm going to replace that. I'm going to actually make another loop so that y'all can see this later. I'm going to say... Oh. I'm like, bro. All right, so let me replace this. All right. Questions on infinite loops? So again, just to reiterate, you want something in your while condition to be mutatable, something that's subject to change, so that we can finally break out of the loop at some point. So instead we're going to compare 3 to x. X is a variable that we know can change. X can be 0, x can be 10, x can be any integer value if x is an integer. If it's a double, it can be any double value, and so on and so forth. So that we know anywhere in this code, we can change the value of x, and once we get back to the next iteration of the loop, there's a chance that we can break out of the loop. We might finally be able to crack that code. Because let's say I have a while loop. Let's say initially x is 0. X is 0, so we get into the loop. We make our way in. Let's say the first line of this while loop is change x's value to 10. Once we get back to the top of the loop, we're going to say, is 3 greater than 10? No. So we're going to break out of the loop. That only was possible because we changed that 0 to be x. We changed that 0 to be x. Questions on why I even made that change? So now for counting loops, this is still using while, but this is like a slightly different way to use them. And to your point, you said, what if we want the user to stop after 3 times or 5 times? This is when we will use like this concept. So a counting loop, also known like in industry as a count control loop, is just a loop that is set to run a specific amount of times. So for the first part of this lecture, we saw loops where we don't know how many times to run it. In this case, we know exactly how many times to run it. It can be 3, it can be 5, it can be any number essentially that you can think of. So it's the same thing as using a while, but it has a slight little twist on it. Like it requires more of you to make it work. So the model we're going to use for this to kind of remember it is ICU. It's 3 steps. Your first step is I. It means initialize. This is going to be a counter. This is going to tell you how many times you run the loop. So it's going to start from 0 normally and go into some other number. So if I want to run my loop 5 times, I would initialize my counter to 0, and I will allow this counter to get up to 5. So it will go from 0, 1, 2, 3, 4, and then stop. That gives us 5 iterations. I'm going to show you the code for it after, but I'm trying to paint the picture now. So C is going to be your condition. Remember in the last slide I compared 3 to the value of x. Instead of x, we're going to use our counter, because our counter is going to tell us when to stop. Lastly, update. So after each iteration of the loop, we need to update the counter, i.e. increase it by 1. So the first iteration, my counter is going to be 0. After I go through the steps inside the loop, it's going to be 1. Then it's going to be 2, then 3, then 4, and then it's going to stop. That's if I wanted to run 5 iterations. And I'm going to show what that really means. Questions on the concept of these 3 steps? Cool. So let's say I want to do a greeting, right? I want to greet the class of 100 students. So I know I have my greeting, that's my instruction that I want to do, and the number of times I want to do it is 100. So kind of going back to my earlier example of just copy and pasting the same thing 100 times, it's like, yeah, we could do that, but let's say we increase it to 10,000 times, that becomes like almost infeasible. So going down the list of steps, our first step is our counter, initialize. This is what initialize looks like. I'm going to initialize some value, some variable called count. I'm going to give it a value of 0. This is what the I step looks like. Next is the C step, which is condition. Our condition, just like an if statement, is going to be while something that goes in the parentheses, and then you're going to start your curly braces. So remember I said once you define your counter, you're going to use it inside the condition. You're going to use it inside the condition. So again, kind of even just taking it from right here, right? Count starts at 0, and we're going to go in this loop while count is less than 100. So count can have a value from anywhere from 0 to 99. Once count finally reaches 100, this loop will stop. So that gives us our 100 like iterations, essentially. And we know our instruction is basically just to print hello class, right? Based on the prompt, I said I want to print hello class 100 times. So I'm gonna say, all right, start me from 0, go until this counter reaches 100. Until it reaches 100, print out hello class. In order for our counter to go from 0 to 1 to 2 to 3, we need to update it, which is the final step, the use step. In order to update our counter, we say count should be what count is right now plus 1. So I'm gonna take whatever value I have right now, I'm gonna add 1 to myself and assign that value right back over. So if count starts at 0, I'm gonna say, nah, actually now count should be 0 plus 1, which is 1. So I'm gonna assign that back over. In the next iteration, count is 1, so I'm gonna say count should now be count plus 1, which is 1 plus 1. So essentially the last step in your loop should be to update. Else this will become an infinite loop. Because let's say I never update, right? 0, let's say this was 0. We're gonna get into the loop because 0 is less than 100. Yeah, well, you said it's gonna stop? It's gonna keep looping because 0 is always gonna be less than 100. We need a way to increment 0 so it becomes 1 and then becomes 2 and then becomes 3 and eventually this thing becomes false. When count becomes 100, this statement is no longer true because 100 is not less than 100. 100 is 100. So once we finally get to that point, this loop will break. This is how we use loops as counters. And so I'm gonna break down each of the steps. Remember I said this first step is what? What is the first step in the model? Initialize. Initialize. This is what we're gonna use to keep track of how many times we have done some instruction or how many times we've run the loop. Initialize is the first step. Second step is what? Condition. Condition. Condition is the second step. This is where we use that counter to see have we finally reached like that point where we can stop this loop. It could be 1,000 times, it could be 100, it could be 2 times. But our counter or our condition is where we use the counter and compare it against some other value. So let's say I change the prompt to say print it out 10,000 times. What would I need to change about my code to make it print 10,000 times? Change the 100. Change it to 10,000. If we didn't have a loop, we would have to try to copy and paste and count exactly how many times it exists. With a loop, it's as simple as just changing this number right here. That's it. And so what's the third and final step? Update. Update. So the final step in the loop is to update your counter. And that allows you to finally get closer to reaching that breaking point in the loop. So if we never updated count has no shot at ever being 100. It has no shot because we never scooted it closer to being 100. We never moved it. So these are the 3 steps. So you probably want to get a photo. Questions on this? I'm gonna go back to the last slide so y'all get the actual any of y'all need this one? This is what you're gonna really need to do your homework. This dude. All right, boom. So now I need y'all help. So again, I saw some of y'all got the pictures. You might want to pull that up. So I want to print all the even numbers from 0 to 10. And your homework is going to look something like this. So make sure you get it in there. I want to print all the even numbers from 0 to 10. Start me off. And count equals 0. Boom. That's the first step. Initialize. Wow. Okay, cool. What goes on the inside? Huh? Right. Exactly. I want to check if some number is evenly divisible by 2, and that's going to tell me if it's even. If it is, I want to print. So this is a combination of a loop with if statements on the inside. Yep. So now I'm saying, while I'm in this loop, if something is evenly divisible by 2, if count, then what do I want to do? See out what?
You need a variable.
Count. Count. Because remember, count is going to go from 0, 1, 2, up until 10. So, like, be mindful of what your I step is, because normally you're going to end up using that as, like, the actual thing that you're printing out. Like, keep a close eye on what's actually happening to that value. So, yeah, if I wanted to print the evens, I would say print that value and then in the line. And I'm going to show what that looks like. Let me make sure that's right. Oh, I compiled the wrong thing. Oh, I never did my final step. I'm like, nah, something wrong. All right, so where would I put the final step at? And see, that's a perfect example of an infinite loop. Where does my final step go? Remember, final step is. And so where does that go? It's the trick. Under what? Under the while? Yeah, I agree. Right. Right here? Yeah, sure? No. I know, yeah, I'm not sure. So this bracket right here ends this year. This is after the if statement. Up here? You said by the while, dude.
The bracket, right there. There you go, G.
So you want it after. It's either you want it after or before. Which one is it? Before. So where I'm typing. So why are you trying to make it? He talking about no, put it by the while. This is like, what? So count equals count plus 1?
2.
Plus 2? There you go. So perfect point. So if I increment by 1, this is like, I guess, necessary. Well, it's like if I'm incrementing by 2, I know every number I'm hitting is going to be even, right? So there's like, this case will definitely work. 1 or 2 will work. 1 would still touch the odd numbers, even though we don't need it to. Yep. So let's see what happens if we do 2. Boom. Yo.
So if you do count plus 2, you don't have to do the if statement.
Right. You basically don't really, because you know that it's going to start from 0 and then go to 2. Yeah. Let's see. Oh, I didn't even my fault. I didn't print out the jump. So in this case, we didn't need the if statement because we know in order to get even numbers, and we count it from 0, which is technically like even, if we just add 2 to 0 every time until we get to 10, we're going to get all the even numbers for free. Let's say we were starting from 1, then it would become kind of necessary to have that, unless you like added some other number. But the if statement would become important in that case. Everybody understand this piece, and this is on ISTEM as well. So I'm not going to. I'm gonna just say, oh, I got it on there. So let's say in this case, club entry, right? Let's say I'm a freshman, I'm 18, trying to go to the club, homecoming around the corner, I want to go to the club. But I'm 18 though. Let's say this homecoming I can't make it, the next one I can't make it. Until I turn 21, I cannot go to this club. Let's say they're not accepting I'm trying to pay more, they like, nah, you cannot come in here till you're 21. So let's say in this case, I want to do the same thing. I already did the I step for us. I already initialized my variable. I can only get out of this loop until I'm finally 21. So how would I start writing the code for that? Wow. What's my condition? Age is less than 21. What do I want to do? Oh, my bad. Damn, my finger's just moving too fast. What do I want to do? What do I want to do every time? Let's say I want to just tell them, just deny them entry. So they say nah or no. If what? We check that here. So we're going to do everything in here. Yep. See ya. Yep. So this is going to happen. So in the initial time, this is going to happen, right? Because 18 is less than 21. So this code is going to execute. Now what do we need to do? Update what?
So count equals age equals age plus
Yep. Yep. So let's say this, in theory, this represents them trying again the next year. So you're going to have the same concept, but like a spin on it, depending on like what scenario you're really trying to accomplish. So let's say we take this code. What was the example from the printing even numbers from 0 to 10? And this is going to be club entry. All right, so let's see what happens.
Don't you need to make a comment at the top
Comment where?
for printing even numbers?
About what?
Comment.
You said put a comment where?
All of it.
no make it out.
To make it
Oh, yeah, if I didn't want any of this to run, I was just going to let it run. But yeah, I can comment it out. So let's see. I forgot I copy and pasted this in.
I'm not sure why that didn't.
Yeah, I don't know. I really don't. All right. So for the first 3 years, they get the no entry, right? Because this is when the age is 18, 19, 20, and finally when they turned 21, they no longer get the nap. They finally got it. So let's say I wanted to print out something after they finally become 21. That would go,
In if statement.
nope, it just goes down here. Yep,
Oh, okay, they'll just leave the loop back.
yep. Because we know we only going to reach this point when the user finally becomes 21. So let's test that out. Because remember, the loop traps them. So nothing after the loop is ever going to happen until the loop finally finishes. So now we saw this is 18, 19, 20, and then it became 21, so it never printed nah bro again. It just finally, yep, it finally did what happens after. So in real code, you'll see a bunch of loops and stuff that comes after the loop. So thinking about the password guesser, right? We would trap them in the password guessing stage, and then after they finally get it, then we could say, here's the access to this page. Exactly, access granted. That's how you want to think about it. If you have some subsequent actions that come after that condition is satisfied, it just goes under the loop. It goes under the loop. And so some hints for when you will use a count control loop is normally when the question contains like some numbers in it. It's telling you go from this number to some other number. So in this case, I just use n because I didn't want to give like an example and trip y'all up, but let's say the question says do something specific from 1 to n. That's a count control loop. Why? Because it's based on the counter. Secondly, do the specific thing n times. Print out hello world 10 times. That's count based. And then lastly, let's say I wanted to print the first n characters of a string. That's count based. That's all substring under the hood really does. It walks through the string in a loop, count based loop, and it prints each character, or gets each character for you. Question.
Yeah. So going back to the game example, right?
Mm-hmm.
Okay, so you know how sometimes you're playing games and you have a limited number of lives.
Mm-hmm.
You could die. If you die this time, you start from a checkpoint.
Mhm.
You will start from checkpoint. But if you die like maybe let's say 3 times,
Mhm.
or you use up all your lives, it's game over.
Yeah.
So how would you write a code like that?
Let me think. Put me on the hot seat. Let me think. So if I had some, let's say I had a loop right here, game example. Let's say I had int current level. I might need to change this. So let's say I had current level, and what's the scenario one more time?
You're the user. You're playing the game.
Mm-hmm.
And you have 3 lives.
Mm-hmm.
So for every time you die, you start from checkpoint. But when you exactly maximum lives 3. So when you exhaust all the lives, it's game over. You have to start fresh.
Yep, got you. All right, boom. So let's say I think this should work. Let's say I have some loop, and I have two variables. I didn't really need to give this a variable. I can just say while lives used is less than 3. Allow user to keep playing and restart from checkpoint. So this hopefully like encompasses that I did. Like I have, or I guess number of lives used could be 0. And then I can say once user dies, increment lives used. So lives used is our counter in this case. And I can say, I probably will have this in some like if statement to say if user dies, if the user dies, then increment how many lives they use. This is probably like somewhere of the idea that I would have for it. Like we're only going to run everything in here while they haven't exceeded the number of lives that they've been given. In this case, it's 3. So I'm allowed them to keep playing and restart from the checkpoint or whatever while they haven't exceeded that number of attempts. And let's say they die. If the user dies, then we will increment our counter, right? Because we're trying to get to that 3 before we can say you need to restart from the very beginning. So I think this is kind of how I would like start figuring out that type of problem, but yeah. Did that answer that?
Yeah.
Other questions? And so just to compare the 2 ways to use a while loop, right? We know we have normal while, and then we have a count control one or count based one. A normal while loop is when we don't know how many times we need to run it. We just know the condition to finally make it stop in the end. That's normally what a regular while loop is. Like the password guesser. I don't know how many times it's going to take y'all to guess my password, so I'm going to allow you to just keep asking. I'm going to allow you to keep guessing while you haven't figured it out. And there's a chance that that condition may never ever be true. With a count-based loop, we know once we reach that maximum count, it's going to break out. Right? Let's say I want to print a greeting 100 times. We know that the only numbers we can work within is 0 to 99. Then we're going to break out. With a password guesser, there's no guarantee that you're going to guess my password correct, right? You might guess it wrong a million times and never get it. In that case, everything after the loop would never execute. Everything after the loop would never execute. It's based on you guessing the correct password. So these are like the trade-offs to using one approach versus another. Count base is always when you know your starting point and your end point. A normal while loop is when you just know your starting point and what's going to make you break out of the loop, but you don't know how many iterations it's going to take. It's kind of like the fundamental difference between the two ways to use a while loop. Questions on this piece? I think this might be my last slide.
We can use count base with CN statements.
Like seeing statements on the inside?
Yeah.
Yep. And so every time it gets to a new iteration, it's going to like do the CN operation again. Other questions? Yep.
Yeah, so for the count control,
Mhm.
the second point,
Mhm.
so the condition for starting the loop is based on how many times you told it to run.
Mhm.
But also, if you get it right, the loop stops.
There could be two conditions. There can be two conditions. One condition is that we haven't exceeded the amount of time. Let's say the pass or a guess are right. Hopefully that's yeah. So boom. Let's say I have some int max, and so this just means hold up. Max attempts equals 10. So this is just going to be some integer variable with a value of 10. That's all this means. Constant just means it can't change. I can't go in and change the value of this variable. I'm kind of showing you that on the fly. But so I'm going to say, while the guess is not correct, and int num guesses, and the number of guesses has not exceeded the max number of guesses. So like this while loop will be based on two conditions now. This code is only going to run while they entered the wrong password, excuse me, and they haven't exceeded the amount of tries. So the amount of tries they get is 10. I'm starting it from 0. So you can have like multiple counters depending on like what your specific use case is. So in this case, let me set it to 3. Let's say I wanted to use it to only have 3 attempts, and I'm going to show that this works. I think that was... So I'm going to enter an initial guess that I know is wrong. And so now I'm inside the loop, right? I'm inside the loop. I get 3 guesses. So I'm going to say lime, strawberry, blueberry. At this point, let's do like orange. Oh, something wrong, my fault. I didn't increment num guesses yet. You're right. Good catch, young blood. Boom. I'm like, dang. Wait. So this infinite loop thing is really real. Like, you forget to do one step, it's just gonna keep you in the loop. So, boom. So my initial guess is whatever. My next guesses are whatever. Once I exceeded that 3, it cut me off. So this is a combination of a normal while and a count-based while. It's a combination. And this is probably what you would really see like on the website, right? They want to see, they don't want you to gain access to the website until you enter the right password and you haven't exceeded the amount of, yep. So this is kind of like an example of that. Yeah, so for example, let's say for all of our other variables besides this one right here, they're changing. So guess is changing based on what the user enters. Number of guesses is our counter, so that's getting 1 added to it every time. These are like mutatable values. Like we can change the value of them. For max attempts, I don't want to change this value. It's a constant. I don't want it to be changeable. So in C++ and for every other language, you have something called a constant. And so this means I can never change the value of this. Once I create it, it has that value for the lifespan of this program. Yep.
Yeah, this question might not be part of this, but you know how sometimes when someone enters more
So let's see. So this is saying while they haven't entered the right password and they haven't exceeded the number of attempts.
When you do it,
So yeah, what I would do, so if we get out of this loop, this could mean one of two things. It could mean either they guessed it right or they exceeded the number of attempts. We don't know which one. We just know one of them made us break out. So yeah, we would need an if to say if a number of guesses is greater than or equal to the max attempts. This would tell us if they exceeded the number of guesses. Then we could do like send email or whatever. Like, let's say we had some function to do that. We would do it right there. If we never check that though, let's say we just rip send the email, that's jumping the gun because we could have gotten to this point just by them guessing the correct password. So it's like we gotta, cover our bases and make sure what we're doing is what we really want. And good question again. Any more questions on loops? Loop questions. All right, boom. So I'm about to put these study guides. Really, I want y'all to work on them together. But I know we kind of, low on time. So I'm putting these in the back. Oh yeah, y'all quizzes in this pile right here on the left, and then the study guide in that pile. Work on them now, please, and ask questions because this is probably going to be what your actual quiz is. Because I'm kind of, Oh yeah, you didn't write your name twice.
Oh, no. Oh, when you was done with the full class?
I figured it was yours. But yeah. Let me make sure.
I literally just got off after that call. I just had my drink.
Huh? You gonna get a study guide?
Alright, trying to play on the guitar.
Alright, hold on.
Hey, Pastor Chris, you give me a
It's up here, it's a study guide. I prefer y'all to do it with each other because I put some of the more trickier concepts on that so you can add it to it. So basically, if you try to change the value of this variable like later on, it's going to say it's a constant you can't change. Say it's constant? Yes. Oh, yeah, I hate that. Yeah, same concept. Oh yeah, y'all homework. Y'all, these the topics. I mean, your study guide encompasses this, but if you want a picture of this to study outside the study guide.
Wait, when you gonna put this on what's called Instagram?
Okay. I gotta get out of the class first.
Hey, you putting the slide?
Wait, what you mean plus recording?
Huh?
What you mean plus recording?
The recording from Lab 4.
It's just cause like
I recorded YouTube when I talked Lab 4. Yes.
oh man.
Go inside the Lab 4. I know you don't do that.
I don't need to go in the like I know how to do the assignment.
And y'all homework gonna be up there after class. I didn't let y'all get access to it because I needed you to learn that.
Yeah.
Check series tonight. Get your quiz. Get a study guide. Huh?
Wait,
I told you
wait,
you were doing
wait.
that shit.
What was on the app or whatever?
Yeah.
How long are you guys here for?
I know, right?
We really are called.
Because like I might just
Or if it's Boston,
When? Today or Thursday? No, but we're gonna have some
think about it.
Cause
I say
or like cause you be seeing this shit.
I be forgetting we added new. I be talking to the same.
I didn't tell you.
It wasn't crazy.
either, right,
But this has to be, I'd be right back.
if it's false, it's false.
Right.
Right?
I don't know.